Hello. In this tutorial, which is within the series of tutorials on Linux, within the series of tutorials on the introduction to software and robotics, we're going to be looking into Docker. If you're randomly stumbling upon this video, this is a speed run of the topic, just to get you up to speed to be able to install things on your Linux machine, basically, or getting code ready for the running something on the robot. Okay. We will cover two basic topics: the information, some basic information on Docker, and then finally how do you install it, and then how do you build an image with it. There will be a predefined image that I have already that installs the code that is needed to run the robots in the robot lab at LTH. Okay, let's start with the basic information on Docker. So Docker is a type of virtual machine that's a Linux virtual machine on Linux. The benefit that you get from this is, I should first talk a bit about what virtual machines are. So it's, you probably heard of game emulation, things like this. So you have your, old Game Boy or something, and well, basically you can treat everything that the Game Boy does as a program, and then have it on your computer as a program, where the program is the entirety of that computer. It's RAM, all of it. If you've ever seen what is it, any percent speed run, you probably were familiar with this topic. But anyway, you can do this with the full-blown OS. And the idea is that the virtual machine that you create is essentially, it functions as if you had a different computer sitting at your desk, and we can do things with it. Yes. Now, what makes Docker special is that it can share some of the resources with the host machine, so with your native Linux, and that means that a lot of the things can be very fast. Now, why would you want to have this? Is well, having a virtual machine, essentially, it isolates everything that you run in it from the host machine. So if you want to be 100% sure that you're using the exact programs between you and your colleagues, between your machine and the production machine. So again, if you have something like a web server, you can check that what you'll push onto the server will be exactly the same as what you had in testing. But then there's security considerations, like isolating things better, and people use it even in production, just to also isolate different components. In robotics, you could have essentially a microservice structure if you want it for your different sensors, for the motors, the vision stack, and so on. And you lose very little speed compared to running everything natively on one host machine. Yeah, very easy development and so on. So this is why you would have it, and Docker is sort of is specialized for things like this. Now, the good thing for shipping code in general is that it runs on Windows as well via WSL or VSL. I've tested the image I have. It's everything's quite easy to install, so you don't even need to have a Linux installed to run Linux things, and you don't need to be bothered with learning I don't know what in the sense of installing things yourself. You can just use a pre-built Docker machine. It's a very nice way to ship software. Now let's discuss one basic concept in Docker is you have what's called a Docker image. This is where you define the virtual machine, so everything that will be installed on it. And the container is then one instance of this image running. So you could have multiple containers running the same image, and the idea there is that Yeah, that's a good thing to have. And now let's look into a Docker file, a sample Docker file that I have here. So you select the operating system you want. Here I have some things to make the installation process a bit easier. And then the important thing is, as you've already seen the introduction to the command line, these things look exactly the same as the installing from a package manager looks exactly the same as it does when you do it natively, let's say, and you just add this run command in between. This is the equivalent of cd. Here I added a user, and I copy some of the files that they have directly into the virtual machine so that it owns it. And I mean, something as simple as this is enough to have an Ubuntu system that pre-installs everything that you need for a particular project. Now, and this is a very simple one where in the end, everything depends on Python, but if the project was written in C++ and you needed maybe some compilation or stuff like this, then you would do the compilation here. So even, this is very simple, but even a more complicated setup really wouldn't be much different. Okay. I will do this part later. Let's talk a bit about how you would install Docker. So you would go to your, you open the PowerShell. If you type in the Windows button and then PowerShell to get into the PowerShell, you just do WSL install. I should have changed this, but to make it prettier. But anyway, all the information is on this link, and you can just go through the defaults. Just do what it tells you. There's nothing really special about it. Then you install Docker on Windows. You do that by typing in Docker to your favorite web browser and search engine, and again just follow the basic instructions. There's really nothing. I have nothing to add to what they have there. And there should be a link to that. I have that. If you are following these tutorials all the way and you want to have the robotic control library, then there will be documentation on how to do this in a bit more detail in the project docs. Let me just verify that I'm not making this stuff up. Installation, installing Docker. No, there is no link. Okay, I will add the link later. Note taken. You will need to create a Docker account. That's because to change some of the settings, they want to have your email. You know the drill with a lot of software. They just want to have some of your data. But out of all the different software companies, Docker is one of the better ones. So I think it will be fine if you give them your email. All right, then. There's a particular setting that you'll need to enable in order to run the particular image I'm about to show you next. And I think you'll actually need this for a lot of other use cases as well. So it might as well be mentioned as like a core step in the installation process, which is you will now. I can't show you this because I'm not on Windows, but in the window on the upper right corner, there will be your some icon that denotes a user, and next to it is the settings. Then in the bar on the left that will be opened, you go to resources, then on the network, and then on enable host networking. That will basically allow the Docker to access your local what is it called? Your local host. Well, there's a video on networking as well that explains this, so I won't go into it here. But essentially, that's it. That's all you need to do in terms of installing VSL and Docker. And yeah, it will be important once you run the actual image that you are in the directory where the image is located, where the Docker file is located, I should say, that describes how the image is, what the image is, what you're building. Okay, and now let's get into this. So we are in the directory of the Git repository URSimple control that has the library. And then I will run docker build. With the T flag, you give it a name for this particular image you're building. Now with this one I have already. Excuse me. So hopefully this won't actually build it from scratch, and it will be like a bit faster. Yeah, see, it skipped a bunch of the steps already. And that's good, because this rats. We should have some water. This whole process will take you about 3 minutes, maybe more, depending on your internet speed, because it's downloading and downloading everything. If you change something in the Docker file and you are building the same image, it will not repeat all of the steps, which is, it has like some it saves the intermediate steps, basically. Okay, now we have it here, and let's run it. Docker run. Okay, now let's explain. Can I wait? No. Okay. Now I can have it. It's a bit more clear. So Docker, the name of the command. Then you specialize it with run. --rm removes. Well, let me just Docker run. Can you give me some options? Yes. --rm. Okay, it doesn't give me the details, so let's just open up the documentation. --rm. Automatically remove the container when it exits. Okay, so once you want this because, you know, at some point you'll turn off the virtual machine and you want it to actually stop running. Otherwise it would continue running in the background. Then the other flags would be, I think we'll have to go back to this, -i and -t. Interactive, that means that it will open up a shell, so nothing fancy there. And let's see what the T is. And T will automatically allocate a sudo tty. That's like if you don't have a graphical interface like this, you are greeted by a tty, which is basically a terminal interface without any graphical options. Now we're running a terminal emulator. That's basically what the tty looks like. Okay, there are further options that we should go over. Okay, so in the --net equals host means that you will share your network card with the virtual machine. So if you're connected to the internet and you have some connection and some IP, the virtual machine will simply have this as well. This will be important as some of the programs we run require the local host. That's why I enabled it earlier. That's not even a LAN. That's just like what you use to for your laptop to communicate with itself, a network of one node. And the visualization software that we use actually runs this way in the browser. Then we have the -e display equals display. That will connect it to your own display. I've verified that this, I don't know if this is necessary on Windows, but certainly is on Linux, and it doesn't. This is tested on Windows, so I mean, it doesn't hurt even if it's there. So you're sharing you're sharing to an extent the display. You're allowing. The details really don't matter. Like I've showed you with the man Docker run, you can find the rest for yourself. Now the V is very important. That with it on the left side of this colon, you say this folder on the host machine will be mapped into this folder on the virtual machine. So they'll share this folder basically, and these folders do not need to be in the exact same places. The reason why you need to share you don't need to share the whole TMP, just on Linux you need to share some of the files that Xorg uses, the thing that defines these windows and so on. In the graphics, I found it simplest if I just share the whole TMP. I've never had any problems with it. If someone who's watching this video knows more than me, please tell me why is this a bad idea, if it's a bad idea. Then we give the name of the image, and finally we say run ZSH. Sort of shell. That's the default shell that I have installed because it has like slightly prettier interface. Okay, and if you want to develop your own code, then you'll have to share another folder, not just the TMP. So let's say I want to share this folder where I'm in the simple control. Then I would say just give me the current directory. pwd prints the current working directory, but now it's in this directory anyway, colon, and let's map it to home student code because that's where the code sits. And now importantly, if you want to actually have the changes, you would need to add the :rw to this. Okay. And let's now go to code. It's going to have the same copy, and let's just try to touch something. Testing file. Okay, if I now exit, I will see the testing file here. Okay, and I mean I can develop stuff right here. Put some numbers in. Now if I go back and run the same thing, I will have the testing file with these changes here. Okay. Let's remove the testing file. All right. So that's it on how you would use all the flags that we need to basically build and to run. You are most certainly encouraged to change the Docker file if you want something else. As these change everything that's here, you run. If I were to if we were to run the Docker and now do install something, make changes that are not change the system files, not these folders that you've shared. Everything will be, these changes will be deleted later on. Okay, I don't know why I didn't want to do that, but who cares? Yes, so be wary of the fact that, if you install something, it's gonna go away when you exit and enter the virtual machine again. We want them actually to be in this sort of a stateless manner. That's what ensures that the code is the same across different places. And yeah, just to I don't know why I keep turning it on and off, but let's just sort of see that we can do stuff from the virtual machine, and that will make changes. I don't even need that. Let's just go there. I'll just run something that opens up that will both open up a window and also use the localhost connection. Let me just pause for a second. Okay, and this flag is visualize manipulator. Do I need to give it anything else? Yes, run in simulation. Okay. Now it's gonna open this in a web browser. Let me see where that is. That's here. Okay, I should actually remove my face to have a bit more space. There we go. Put this on the side. Okay, now this is running from the Docker, and we have it visualized here. And okay, it expects some coordinates, and now it's going to open up a window that does some plotting as well. So yeah, all from the virtual machine. That's why we had to give it all these flags. All right, I think that's it. You have enough to start using Docker. And yeah, this is. If you have any questions about the particulars of the Docker image for the library, please send them to me, and I'll try to answer them as quickly as possible. Okay, hope you learned something.